Good morning, students. I, Sumit Sharma, faculty of Information Technology Department, Ajay Kumar Garg Engineering College, going to discuss about the software engineering. It's helpful for those who are studying in the third year related to CSC or IT department branch. So we are here to discuss first what is software, what we understand by software. Software is defined as a tool with designated order of instructions performing tasks to provide the desired results after obtaining the requirement of the user. So, software also consists procedures, rules, related documents, and the associated basic data required to run the software. So, we can easily see that software is basically a program, some procedures, some rules, and then usse related documents, and then the data which we require to run the software. So, procedure and rules include step-by-step instructions to install and use the software. Documents include requirement documents, design documents and test related documents. ठीक है, तो टाइप ऑफ सॉफ्टवेयर क्या क्या है, लाइक आप जनरल यूज में जो सॉफ्टवेयर यूज कर रहे हैं, लाइक वर्ड हो गया, एक्सेल हो गया, पावर पॉइंट्स हो गया, लिनक्स हो गया, एसक्यूएल हो गया, फोटोशॉप हो गया, आप एप्स जितने सारे यूज कर रहे हैं अपने मोबाइल फोन्स पे, दे ऑल आर नोन एज द software. They have certain procedures, step by instructions, how to use the software, and then some documents related to those to that software. How the software always involving into the current scenario. Software as a product which basically transform the information, produce, manage, acquires, modifies and display. As a vehicle for delivering product like OS tools, due to failure and over budget rates are high, and then due to success it's evolving. Hardware and software cost is decreased by the time. Manager and technical person ask, why are costs so high? Why can't we find all error before release? Why do we have difficulty in measuring the progress of the software development? Do we understand what is the meaning of crisis? What we basically understand the meaning of crisis. Crisis is basically known as a problem which we generally face when we develop the software, and it causes many issues. So, software crisis is basically a term used in computer science for the difficulty of writing useful and efficient computer programs in the required time. Software crisis was due to using some workforce, कुछ भी हो सकता है, some methods, some tools, even though rapidly increasing software demand, complexity of software and software challenges. With increase in the complexity of software, many software problems arise because existing methods were insufficient. If we use same workforce, same method, same tools, after fast increasing in the demand, complexity and challenges, then there arise some problems like budget problem, efficiency problem, quality की problem है, managing the delivering problem है. These are the kind of problems we generally face once we develop the software. So these are all are becomes known as the crisis. Why the software is becoming fail? What was the problem we were facing while developing the software? So crisis, early software development was personalized. As sophistication of application grew, programs grew in size and complexity. जब size बढ़ता गया तो maintenance become difficult. Projects were taking lot longer than originally calculated duration. Cost a lot more to develop than initially estimated. क्योंकि टाइम बढ़ा तो कॉस्ट भी बढ़ा, जितना हमने एस्टिमेशन किया था उससे ज्यादा हमारा कॉस्ट लग रहा है. सॉफ्टवेयर वॉज बीइंग डिलीवर्ड टू द कस्टमर ओनली टू फेल. एरर फाउंड बाय द कस्टमर वर एक्सट्रीमली डिफिकल्ट टू ट्रेस एंड fix. Large size project failed due to some reasons like development teams exceeding the budget. हम डिलीवरी लेट कर रहे हैं सॉफ्टवेयर की, उसकी क्वालिटी उस प्रकार की नहीं है जितना हमने उसमें कॉस्ट इन्वेस्ट किया है. We are not completing the requirement as we got from the user. It being very difficult to maintain the software, and we cannot handle or we cannot use them easily. These were the crises which we generally measure into the development of the software. So, demand बढ़ रही है, complexity बढ़ रही है, challenges बढ़ रहे हैं. We have the same workforce, we do not upgrade the workforce. We are not having the upskilled developers. We are using the same process, same methods of development. We are not changing it. That's why the crisis is arising. We are using the same kind of tools, even though the new tools has been arise into the market. Software crisis के main कारण क्या हैं? The cost of owning and maintaining software was as expensive as developing the software. The cost of owning and maintaining software was as expensive as developing the software. At that time, projects was running overtime. Software was very inefficient. Quality is very low. It does not meet the requirement. Average software project overshoots its schedule by half. At that time, software was never delivered. So we have not doing the proper guidance or proper management to develop the software within the time frame and completing the requirement of the user. Solution क्या है? What are the solutions of the software crisis? There is not a single solution. What we have got the problems, those can be the solution of the software development. So as we see that there is no single solution to the crisis, one possible solution of software crisis is engineering, because software engineering is a systematic, disciplined and quantifiable approach. For preventing software crisis, there are some guidelines like reduction in over budget, quality could be high, time should be less, means we develop the software within the time frame. Experienced working team members should be on the development, and we must deliver how much we have done so that we can easily identify the progress, how much we have met the requirements. Failure के examples क्या थे? Like Y2K problem, we all understand. Windows XP in October 25, 2001. These were some failure example of software. Now we talk about the software engineering, why we learn software engineering, what is the advantage of learning the software engineering. In traditional method, we can easily develop the software, and we do not follow any kind of procedure to develop the software. We just gather the requirement from the user, and we generally try to develop writing the code, and without designing, we develop the things. Fine. So engineering says the systematic processor. In the systematic manner, you can develop the software. The initial phases, which is essential to do, we have complete those phases first, and then we do the development. So as we understood that the software consists program, documentation and the operating procedures. So these all things becomes the software. So what is program? Program is basically the subset of the software, because in software, it's basically the collection of the programs becomes the software. Fine. So it has the source code and the object code. Documentation means describe the operations and the how we use that program. Fine. So the documentation manuals, कौन से होते हैं? Requirement specification, analysis specification, in which we have the formal specifications, context diagrams, data flow diagrams. Then we have the design documents. In that we have the flow charts, ER diagrams. Then the implementation, we have the source code listing and the cross-reference listing. Testing have the test data and then the Operating procedures, user manuals having the system overview, beginner's guide and then the reference guide. Operating manuals installation कैसे होगा, administration की क्या क्या guidelines हैं, and these are the some list of operating manuals. Now we talk about engineering. Why engineering word is being added with the software? So it is basically the process of designing and building something that serves a particular purpose and find a cost-effective solution of that problem. Fine. It's the skill, profession of acquiring and applying the scientific, economic, social, and practical knowledge in order to design and also build structures, machines, device, materials, and process. Manufacturing is the production of goods for use of sale using labor and machine tools, chemical and biological processing or formulation. Now, software engineering is basically the engineering discipline which is concerned with all aspects of software production. Software engineers should adopt a systematic and organized approach to their work, use appropriate tools and techniques depending on the problem to be solved, development constraints, and use the resource available. So, according to the IEEE definition, we find it's the systematic, disciplined, and quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to the software. According to Bohm, the practical application of scientific knowledge in the design and construction of computer programs and the associated documentation required to develop, operate, and maintain them. So this is the definition of IEEE and this is the definition given by the Barry Bohm for the software engineering. So engineering methods, basically what engineering signifies us, use of methods, procedures and the operating standards. Fine. Tools and standards. Methods give the different steps you have to take: projects planning, estimation, requirement analysis, designing and development, algorithm development, coding, testing and maintenance. Tools provide automated support for the methods like case tools, coding tools and then the testing tools. And procedures क्या करता है define? Sequence in which the methods are to be executed. Software engineering today, having the engineering management, having the requirement analysis, engineering infrastructure, process, evolution and maintenance, quality, configuration, testing and construction. Now we talk about the characteristic. Software does not wear out. The significance of software does not wear out means like hardware, if we design a hardware and it breaks, it cannot use again. While in case of software, we can use the software again by some modifications. In hardware, we can do some modifications and joints. We can use those hardware, but the strength will be less. But in case of software, if we modify the things, we can use the software again. Software may be retired due to some environmental changes, new requirements, new expectations. This is the failure rate. As the time increase, the failure rate is less. Now, software is not manufactured, it is developed. The life of a software is from concept exploration to the retirement of the software product. It is one-time development effort and continuous maintenance effort in order to keep it operational. However, making 1,000 copies is not an issue and it does not involve any cost. In case of hardware product, every product costs us due to raw material and other processing expenses. Hence, it is not manufactured in the classical sense. It's logical rather than physical. We cannot touch. Reusability of the component. Once we have designed some functions, we can use those functions again into the different kind of software. It is flexible. Moderation can be done anytime, anywhere. Most software is custom built rather than being assembled from the existing components. What are the myths related to the software? First is the management myth. We already have a book that is full of standard and procedures for building software. Won't that provide my people with everything they need to know? Yes, the procedures and standards has been maintained to build the software, but no one can easily write the use those procedures and standards and develop the software. Reality, the very well exist, but is it used? Are the practitioners aware of its existence? Is it complete? Is it adaptable? In many cases, the answer to all is no. If we are getting behind the schedule, we can add more programmers and catch up. No, it cannot be. Software development is not a mechanistic process like manufacturing. Adding people to the late software project makes it later. Spending time educating the newcomers, thereby reducing the amount of time spent on productive development time. People can add it, but only in a planned and well coordinated manner. The myth is that if I decide to outsource the software projects to a third party, I can just relax and let that firm build it. The reality is that if an organization does not understand how to manage and control software project internally, it will invariably struggle when it outsources software projects. सॉफ्टवेयर मिथ में नेक्स्ट है कस्टमर मिथ कहता है ए जनरल स्टेटमेंट ऑफ ऑब्जेक्टिव इज सफिशिएंट टू बिगिन द writing programs. We can find the details or fill the details in later. Formal and detailed description of the information, domain, function behavior, performance, interfaces, design constraints, and validation criteria is essential. The characteristic can be determined only after thorough communication between the customer and the developer. Software myth says project requirements continually change, but change can be easily accommodated because software is flexible. Is that true? No. It is true that software requirements change, but the impact of change varies with time at which it is introduced. If we change the requirement after the design can be changed again. So it is not easy to say that we can accommodate that change later on. So it can change the duration. The duration in developing the software may be increase. If serious attention is given to upfront definition, early requests for change can be accommodated easily. Customer can review requirement and recommended modifications with relatively little impact on cost. When changes are requested during design, the cost impact grows rapidly. Resources have been committed and a design framework has been established. Change can cause uphill that requires additional resource and major design modification, that is additional cost. Change in function, performance, interface or other characteristic during implementation have a severe impact on the cost. Change when requested after software is in production can be over an order of magnitude more expensive than the same change requested earlier. Practitioner myth says once we have written the program and get it to work, our job is done. Reality क्या है इसमें? Someone said that the sooner you begin writing code, the longer it will take to get done. Industry data indicate that between 60 to 80% of all effort expended on the software will be expended after it is delivered to the customer for the first time. Myth says if I get the program running, I have no way of accessing its quality. Reality says one of the most effective software quality assurance mechanism can be applied from the inception of a project, the formal technical review. The myth is that the only deliverable work product for a successful project is the working program. Working program is only one part of a software configuration which includes many elements. Documentation provides a foundation for successful engineering and more important guidance for software product support. The myth is software engineering will make us create voluminous and unnecessary documentation and will invariably slow us down. Not about creating document. Software engineering is not about creating the documents. Truly, it's not creating. We are not creating only the document. It is creating quality. Better quality leads to reduced the rework, and reduced rework results in the faster delivery within the time. Now we talk about process. What is software process? So Webster says a system of operation in producing something, a series of action changes or functions that achieve an end or a result. According to IEEE, a sequence of steps performed for a given purpose is known as a process. Process is basically program in execution in general ways we understand, but in terms of software engineering, it is little bit different. According to the Pressman, Roger S. Pressman, the software engineering process is basically the glue which holds the technology layers together and enables rational and timely development of computer software. Process defines a framework for a set of key process area that must be established for effective delivery of software engineering technology. The KPA form the basis for management control of software project and establish the context in which technical methods are applied, work products are produced, milestones are established, quality is ensured, and change is properly managed. So, it concludes many things here. This is common framework. Framework की activities क्या है? Task set, milestone deliverables, SQS, software quality assurance points under the umbrella activity. So a common process framework is established by defining a small number of framework activities that are applicable to a software project, regardless of their size or complexity. Several task set, each a collection of software engineering like work task, project milestone, work products, and QA points. Enable the framework activities to be adapted to the characteristic of the software project and the requirement of the project team. Umbrella activities like software quality assurance, configuration management, measurement, deployment, overlap the models, and umbrella activities are independent of any one framework activity that occur throughout the process. Difference between software engineering and traditional engineering में क्या difference है? Software is intangible. It does not degrade with time as hardware. Software failure may caused by design and implementation error, not by degradation of over the time. In classical engineering disciplines, the engineering is equipped with tools and the mathematical maturity to specify the properties of the product separately from those of design. The typical software engineering relies much more on experience and judgment rather than mathematical formula. So these are the difference between the traditional engineering and software engineering. Engineering deals with software that is logical in nature, no volume, no mass, no color, no order, like intangible. While other engineering approach, mechanical, electrical, deal with the physical entities, and these physical entities have weight, color, mass, and they are tangible. In software engineering, there is no fundamental laws in software engineering which guide development, design, and implementation of the software. While in other engineering, fundamental laws in other engineering that guide the development process. Software does not wear out with time. It is conceptual in nature, so it is not affected by factors as dust and rain. While in other engineering wear out with time as a result of physical or electrical changes. Environmental factors like dust, rain do not affect on the software, while other engineering, environmental factors like dust, rain have effect onto the software product basically. Now quality, what do you mean by the quality? It basically conformance of the explicitly stated functional performance requirement, explicitly documented development standards, and implicit characteristics that are expected of all professional developed software. Macaulay's quality factors क्या थे? They have given the two categories of software quality factors. Factors which can be measured, directly measured, and which can be measured indirectly, like bugs or defects, like usability or maintainability. Both sets can be measured. McCall, Richards, and Walter groups these factors into three categories focused on three aspects of the software product, like operational characteristic like product operation, ability to undergo change means product revision, and then product अगर हम adaptability to new environment, this is known as the transition. तो तीन quality, three layers से उन्होंने आपको बताया, operation, revision and transition. Transitions में क्या है? Portable होना चाहिए, reusable होना चाहिए and interoperability होना चाहिए. While revision says maintainability, flexibility and testability, and while operation says correct होना चाहिए, reliable होना चाहिए, usable होना चाहिए, integrity होनी चाहिए and then efficiency होनी चाहिए. It includes 5 software quality factors related with the requirement that directly affect the operation of the software, such as operational performance, convenience, ease of usage, and its correctness. These factors help in providing a better user experience. Correctness, the extent to which a program satisfies its specifications, fulfill the customer's mission's objective. Correctness का मतलब क्या है? Whatever input we are giving, according to that inputs, it produces the correct output. Means it must satisfy the specification and the objective of the customer and the functionality. Reliability, the extent to which a software performs its intended functions without failure. Fine. Usability, the extent of effort required to learn, operate and understand the functions of the software. Integrity says the extent to which access to the software or data by unauthorized person can be controlled. Efficiency, the amount of hardware resources and code the software needs to perform a function. Product revision, it includes 3 software quality factors which are required for testing and maintenance of the software. They provide ease of maintenance, flexibility and testing effort to support the software to be functional according to the needs and requirement of the user in the future. Maintainability says the effort required to detect and correct an error during maintenance phase. Flexibility says the effort required to modify the operational program. Testability says the effort required to verify a software to ensure the quality which meets the specified requirements. Transition says portability, reusability and interoperability. It includes three software quality factors which allows the software to adapt to the change of environment in the new platform or technology from the previous. Portability, the effort required to transfer the program from one hardware or software system to the another. Reusable, the extent to which a program or the part of the program can be reused in the other applications. Interoperability says the effort required to couple one system to another. Now we talk about the software development life cycle. It's an easy and systematic process for building softwares that ensures the quality and correctness of the software built. Life cycle model take care of the order of the activities performed on a software product from its inception to the retirements. Different life cycle models may map the basic development activities to phase in the different ways. Thus, no matter which life cycle model is being followed, and the basic activities are included in all life cycle models. Models through the activities may be carried out in different order in different life cycle models. During any life cycle program phase, more than one activity may also be carried out. So, what is the need of SDLC? Development of software product in the systematic and disciplined manner, clear understanding among team members about when and what to do. Each phase defines entry and exit criteria for every phase. Fine. So I stop here, and the next video we will discuss about some models of the software development lifecycle and how those models can be used in the current scenarios. We'll discuss in the next video lecture. Thank you guys.